Hello, my name is Joe Wheaton from Utah State University, and I'm going to pick up where Jeremy Maestas left off, talking to us about a shared vision for riverscapes and working lands, and that is one of resilience. And I'm going to just sort of backfill a little bit on the need for low-tech restoration as we define it and cover it in this workshop. I'm going to do that by talking a little bit about the scope of degradation of riverscapes and the cost of our traditional approaches to restoring that. This is a really simple problem to state. The scope of riverscape degradation is massive. In the U.S. alone, we're spending well over 10 billion annually, and we're barely scratching the surface of the problem. I would argue that we spend a disproportionate amount of money on too few miles of streams and rivers, leaving behind millions of miles that are neglected. No matter how you want to slice this, on the left here is an example from the 2007 US EPA's Wadeable Stream Assessments, and this is just the poorest of the poorest, and depending on what indicator that you use, we're talking about hundreds of thousands of miles of the poorest condition. If we include that to include other indicators that are well below our quality standards, it's a much more depressing sort of story. So you could summarize that as, there's 1 to 2 orders of magnitude more miles of riverscape in need of help than we currently pour our money and effort into. My colleague Hervé Piguet from the Riverscapes Consortium argues in a recent proposal, rivers are the most impacted ecosystems worldwide, a bunch of recent studies supporting that, and freshwater ecosystems are experiencing stronger rate of biodiversity loss than ever. These are scary, and so it's also important that we pull back and define what a riverscape is. You may have heard rivers, you may have heard landscapes. Um, Riverscape is really a shorthand to get away from having to talk about rivers or streams. It's both. It's more than just those freshwater ecosystems. It's that collected fluvial system that spans the entire drainage network across a watershed, but includes their floodplains. So riverscapes are the part of the landscape that could plausibly flood by their rivers and streams in the natural flow regime. So keep that definition in mind as we proceed throughout this workshop and the modules. The scope of the riverscapes problem is, at least in the semi-arid West, is we have a lot of this. Here's a creek, and you could look at this, and when we as restoration practitioners look at it, if we don't just turn a blind eye to this and give up, what we look for in terms of opportunity is pretty much constrained down in this channel. Now, if we pull out of that channel and take a look at this and try to think about what's been lost, what I've got delineated in yellow is our definition of a riverscape. That is the valley bottom. That's the area that could plausibly flood in the contemporary natural flow regime if conditions were better. And this is an incised degraded ditch in a channel that was straightened. And so right now we've got this little kind of wimpy active channel. We've got a little wimpy active floodplain. And to really highlight what's been lost, it is this portion that used to be potentially active floodplain and or channels. So that's a visual for scope of degradation. Those of you that don't come from arid environments, we have a lot of rivers that just because they have more vegetation on them doesn't mean that they're in great shape. So we can refer to these as structurally starved systems a lot of the time when they are lacking structure like wood, like beaver dams, boulders, etc., that diversify those flows and promote that connectivity or a larger proportion of that valley bottom as active. So this one's really deceptive. There's a young forest, but it's really low wood input. It's locked in place. This is actually alder, which is sort of a disturbance species. And this particular system looks more like a bowling alley than it does like a functioning system. Yes, there's a few little sticks and twigs that have come in, not much hydraulic purchase. There's a few sort of remnant armored boulders, but this vegetation, while maybe providing shade for the stream, is really locking in place a totally unnatural channel form here. And so these are very efficient conveyors of water. So our underlying premise to one of the major problems that explains the scope of degradation of riverscapes is structural starvation, starvation of the structure. And if we look here, this is an example from the Columbia River Basin in the United States from Riemann et al. You can see a whole history of various basically assaults on our riverscapes, starting really with the fur trade and trapping of beaver, moving into mining, railroads, agriculture, logging. There's a whole host of uh, different drivers and land uses that have led to structural starvation and to the degradation of many of these systems. But don't fear, we have Tonka toys, right? So this is our typical sort of restoration procedure. If you do restoration, it's very akin to doing surgery. So we have a lot of channel realignment and grading projects, and you start by shaving, clearing the surface, remove vegetation, so you can open the system up cleanly, cut an access route in, so you can get that equipment in. We do the actual operation. We do our grading and adjusting of that system, and then we stitch it back up. We may reseed, put erosion control, planting, and then because we're really afraid of this system adjusting and not looking exactly like we built it, we often use preservatives like riprap over the fear that it might adjust or exercise. It's about like putting a cast on and forgetting to ever take the cast off. And so this restoration practice, there's times and place for this, but basically this leads to detailed designs based off of topographic surveys, a focus on stability because it's predictable, low density. If we do put, like here, there's a bunch of wood being put in on the outside bend. Very, very common, right? Because the outside bend might erode the bank if you don't put a bunch of expensive root wads on there. And we build constructed habitats that are all designed to prevent erosion. So this results in restoration that is very high cost per mile. And there's places where this absolutely makes sense. However, I would argue that there are many more orders of magnitude of miles of our riverscapes that are not right like this one through downtown Reno that need such a heavy-handed approach. So the cost of that traditional approach, it's kind of scary when you do a Google search for stream restoration. The first things that come up are indeed yellow iron Tonka toys. These are sort of the standard tools of the trade, and like I said, they can be useful, and indeed we ourselves sometimes use them sparingly. But if we want to think about the health of riverscapes, I would hope that it's not always a surgeon that we need to provide an uplift in our health. It might be things like focusing on our diet and our exercise for these systems. The restoration economy in the United States is a big business. This is probably an underestimate from 2015 from Bendor, putting it at something like 10 billion a year, with an overall impact closer to 24 billion per year. And in terms of jobs, et cetera, this actually does compete with other industries that we hold in pretty high regard. These big price tags, though, despite them, they have a minuscule footprint. This is from Bernhard et al. In 2007, and even back then, median project cost was about 150,000. Average length was about half a mile, putting things at close to an average restoration price tag of 270,000 a mile. So another sort of conclusion of a similar thing puts that range between 65,000 and 350,000 miles. Well, we have over 5 million miles of rivers and streams in the United States alone. And depending on how you want to look at them, at least half of them, probably a lot more, in need of some love. We simply can't afford to keep doing business as usual. We desperately need scalable solutions. And I have colleagues that sort of, laugh at me dismissively that, well, oh yeah, all that stuff just working in little wadable streams, how important can that be? I work in big rivers. Well, in green here, I have a sixth order river, a bigger river on this particular watershed. This could be anywhere really. And yeah, those rivers can be important, but they also represent a minuscule fraction of the total drainage network. The wadable streams that make up the vast majority of the length of this, if we want to talk about overall system health, are fundamentally important as well. So our desired attributes of low-tech restoration, it's something, these are going to need to be techniques that are simple and hopefully cost-effective, such that they can be efficiently scaled up to this scope of degradation we're talking about. If we need to build structures, they should be built with natural materials, hopefully hand-built, and we should be relying more on the system to do the work. This overall approach allows more people to participate. If we think of our treatments more like meals for a system, helping it back to health and facilitating its exercise, more people can participate in preparing meals than participating in surgery. And this does encourage us to take calculated risks in planning and permitting, design, implementation, monitoring, and evaluation, which are the modules that we're going to be covering for you. So I'm going to leave you with a definition of low-tech process-based restoration from the design manual. This is on page 16 in one of the glossary of terms. So a practice of using simple, low unit cost structural additions to riverscapes which mimic functions and promote specific processes. The hallmarks of this approach should include an explicit focus on promoting geomorphic and fluvial processes, a conscious effort to use cost-effective low-tech treatments because of the need to efficiently scale up application, and letting the system do the work, which defers critical decision-making to riverscapes and or beaver. So with that, I will hand things over, and we're going to listen to first Colin Thorne talk about a reference condition. If you need an analog, you need a target, and one that's been missing from our vocabulary and sort of scientific frame of reference. And then we'll hear from Mark Beardsley about how we can reimagine what riverscapes could be. So I'll leave you with that. Thank you very much.